Good morning, classmates. So this is my report, gas disk and origin of UV radiation. So let us go to the slides. So a gas disk is also called accretion disk. Accretion disks are flattened astronomical objects made of rapidly rotating gas, which slowly spirals onto a central gravitating body. So this is the picture of an active galaxy named M87. So as you can see, here is the gas disk in the nucleus shown in the picture. How is accretion disk formed? An accretion disk is a flattened circular or elliptical structure that is formed when materials falls towards a strong gravitational force, such as a star or a black hole. So in our topic today, it will be the black hole. So this disk called an accretion disk, right? So nag-heat up siya. Heat ups due to gravitational and frictional forces at work. So models of active galaxies also a region of cold gas, dust, thought to be in the shape of a giant donut with a black hole, and accretion disk nestled in the donut's hole.
We all heard what black holes are.
Sorry. There.
We all heard what black holes are.
Okay. There.
We all heard what black holes are. Let's not get into that even light cannot escape, blah blah. They are regions of space where gravity is really strong. Because matter has been crammed into such a small space, gravity is very powerful. This can happen when a star is dying. People cannot observe black holes because no light can escape outside. Hence, they are invisible. When matter falls toward a black hole, it does not fall straight into it. Instead, it forms a large, thin disk as it spirals around the black hole. This disk is known as an accretion disk, a disk-like flow of gas, plasma, dust, or particles around a black hole in which material orbiting in the object's gravitational field steadily spirals inward, losing energy and angular momentum. The term accretion is used in astronomy to describe the increase in mass of any celestial object due to gravitational attraction. The astronomical object whose mass is increasing is known as the accretor. Although no one has ever seen a black hole or even its event horizon, we can observe the accretion disk because the spinning particles are pushed to incredible speeds by the black hole's massive gravity, generating heat and intense X-rays and gamma rays out into the universe as they collide. When the matter being accreted has enough rotational or angular momentum, it cannot simply fall inward into the black hole in a straight line. An accretion disk forms. The flow tends to flatten into a disk in directions perpendicular to the black hole's rotation axis because the rotation prevents the inflow of matter. Matter contracts toward a plane in directions parallel to the rotation axis until the heat pressure inside the accretion disk approximately equals the gravitational force. The accretion disk will be geometrically thin, and its thickness will be much smaller than its radial extent if the heat pressure, which resists compression, is minimal compared to gravity and rotation, which causes the accretion disk to contract vertically. If pressure forces are comparable to rotation and gravity, the accretion disk will be geometrically thick, looking more like a torus than a disk. Due to turbulence and viscosity, the matter within the accretion disk spirals inward, losing energy and angular momentum. The material orbiting the black hole would swiftly sink toward the equatorial plane of the accretion disk in the absence of any viscosity, turbulence, or other types of friction, and then continue to travel in circular orbits. For matter to flow inward, for accretion to occur, Some type of friction that dissipates angular momentum is required. Viscosity in the black hole is too low to generate inward drift at the densities and temperatures found in accretion disks. The friction is considered to be caused by turbulence due to the rotation of the accretion disk increasing any magnetic fields that already exist. The effective viscosity that pulls matter inward while conveying extra angular momentum outward is provided by turbulence. As the accreted material falls or spirals inward, accretion disks generate enormous amounts of energy from converting gravitational potential energy into radiation. In the black hole, accretion can release energy more efficiently than thermonuclear reactions, and is thus assumed to fuel the universe's most energetic objects, such as quasars, radio galaxies, and X-ray binaries. The primary sources of the mass supply for the accretion disk material can be from a companion star, in the case of X-ray binaries and cataclysmic variables, the interstellar medium in the case of active galactic nuclei, or dust and gas in a protoplanetary disk in the case of planet formation. The accretion disk's physical state and chemical composition are determined by the physical conditions inside the disk and the source of the accretion disk material. The temperatures in the accretion disks range from a few thousand to several million kelvins. As a result, the accretion disk emits light with wavelengths ranging from infrared to low-energy, soft X-rays. Parts of the accretion disk may evaporate, forming an even hotter, low-density corona, comparable to that of the Sun, releasing high-energy, hard X-ray radiation. Other accreting objects like quasars, radio galaxies, X-ray binaries, and newborn stars produce supersonic jets that eject a portion of the accreted material from their poles. It is generally assumed that these jets are probably propelled by magnetic forces emerging in the magnetic field lines that are helically twisted by the rotation of the accretion disk and directed perpendicular to it. If you like this video, please consider subscribing and click the notification bell so you do not miss any upcoming videos.
Okay, so that is the explanation, further explanation of the accretion disk. So here's the picture of the accretion disk, as you can see there. Yan na po yung hot tin rotating disk. So, pinakita ko lang kung nasaan siyang part. Yan lang nag-rotate, nag-spin siya towards sa black hole. Another report that I'm going to share is the UV radiation. Though no light can escape from the black hole itself, we can detect the matter is pulled into the black hole. So as the matter falls toward the black hole, it gains energy and heats up, emitting ultraviolet rays, X-rays, and gamma rays. So how does it emit? How does a black hole emit radiation? This one is what's it called? The picture of a light bar made in the lab experiment na nasa baba. Pero yung isa, ito yung Hawking radiation. So kung paano natatrap yung mga materials sa loob, yung virtual photon pairs na nagpa-pop out siya nowhere, tapos parang ini-highlight nila each other. Yan mga red saka yellow na nakatrap dyan. Pero yung mga photo nagpapass over sa event horizon, nakita yung yellow, yan. Nakapaloob dyan, natrap dyan. So, yan na yung nag-i-emit as Hawking radiation. So, nakikita mo naman kung paano yung mga arrows dyan. So, as the gas orbits, magnetic stress cause it to lose energy and angular momentum, thus spiraling slowly towards the black hole. So, the orbital energy is transformed into thermal energy. So, heating up the gas into millions of degrees. So,